In this video, I am going to discuss chemical bonding, some important topics. Hybrid orbitals, pure orbitals calculation, sigma bonds, pi bonds calculation, bond order, bond length, bond angle, bond parameters. What is the relation between bond order, bond length and bond energy also I will give. The 6 topics I am going to give explanation including shortcuts. This is bond energy. So first, let's begin with first topic, that is hybrid and pure orbitals. Hybrid and pure orbitals. We are seeing in our examination a hybrid orbitals, pure orbitals calculation, and they are asking ratios, and only they are asking hybrid orbitals. So different questions they are framing. So how to calculate hybrid orbitals? First I'll give you clear explanation, then come back to the shortcuts. Students, first hybrid orbitals. I am taking one example, that is ethane molecule C2H6. C2H6. C2H6, what is this expanded form? CH3. If you want to write little more expanded form, yes, you can write. So around this carbon 3 hydrogens and single bond, it has again 3 hydrogens. You can write and give the hybridization. So how easily we can write hybridization? We have discussed some shortcuts in the previous videos, and here again I am giving. So here carbon, both the sides single bond. What is this hybridization, students? sp3. Carbon at least one side double bond, that is what? sp2 hybridization. Carbon at least one side, both the sides. While giving hybridization, we have to check both the cases, both the sides. Then this is sp. And next to carbon condition is like this, both the sides double bond. This one also go to the sp hybridization. Why we selected sp hybridization? Why we are giving sp hybridization means, look into here. Here single bond, just a single bond is there, then what we call it as, students? Sigma bond, right? So if it has double bond is there, one sigma, one pi. After sigma bond formation only pi bond formation takes place. Pi bond is weak bond, sigma bond is strong bond. So suppose 3 bonds is there, one is sigma only one always, and remaining 2 are pi bonds. This is the way we are calculating. Now come back to this one, here 1, here 1. This is sigma bond, here out of 3 bonds, 1 sigma. So totally here 2 sigma bonds, 2 pi bonds, right? Here also out of 2 bonds, 1 sigma, 1 pi. Here 1 sigma, 1 pi. Totally here 2 sigma, 2 pi bonds. See, after calculation of sigma and pi bonds, this is very close to the sp hybridization. That's why we have given sp hybridization. Clear, students? Now come back to this example with concept. I will explain concept. Then we will discuss the shortcuts. Ethane molecule, how many hybrid orbitals they are asking. In ethane molecule, we have 2 carbons. Each carbon undergoes sp3 hybridization. See, look into this, students. Yes, both the sides single bond. No? Actually, concept, what is the concept here, students? Come back to the concept. Carbon, it is undergoing sp3 hybridization. To show this one, I am taking electronic configuration. This is ground state electronic configuration. Outermost shell only we are considering, only outermost shell participating in bond formation. So remaining core electrons, these electrons with that particular atom only, participation is not there. Any atom, we are speaking only outermost shell, that we call it as valency electrons. Clear? So ground state I am taking here, that is 2s2, 2p2. So ground state, if you write box method, S means how many boxes, students? Single box. Yes, it has 2 electrons. If you have any queries, any doubts, and confusing while writing electronic configuration, don't worry. I have uploaded 2 videos, electronic configurations, including exceptional cases had given. So please go through that, our electronic configuration topic in our channel, then come back to this. 2p2. Here 1, 2. So Hund's rule. In my hand, 2 electrons are there. According to Hund's rule, these are degenerate orbitals. First electron spilling, then pairing. So I have given explanation. Please watch it. So now excited state. Excited state means the paired electron jumps vacant orbital. So here, what is the output finally? 3 unpaired electrons here 1 unpaired electron. This is 2s, this is 2p. These 4 are involving in hybridization. 2s orbital plus 2p orbital. 2p how many? 2p3, right? So finally 1s orbital, 3p orbitals are involving in hybridization. We will get 4 hybrid orbitals. So 1s orbital, this is we call it as, each box we call it as atomic orbital, AO. So 1 is 3p, 1 plus 3, 4. 4 atomic orbitals are involving in hybridization. So finally I will get 4 hybrid orbitals. Number is not changing, but what is changed here? Energy changes. Right? What is energy changes? According to Aufbau principle, we came to know that 2s has less energy when compared to 2p. So before intermixing, before involving in hybridization, 2s have low energy, 2p has more energy. You can write like this. Once intermixing, you will get 4 hybrid orbitals, right? 1s orbital and 3p orbitals. 2s, 2p. 2s, 2p, but here 1s orbital, 3p orbitals, totally 4 atomic orbitals are involving with different energy. Once intermixing, exchanging the energies, so 4 hybrid orbitals having same energy will get. So here you can expect the questions. 4 atomic orbitals are involving in hybridization. How many hybrid orbitals will come? Same number will not change. But what is the change here? Energy. Here it may be different energy, but here it has same energy. So like that I am showing. Clear point, students? So finally what I am trying to see here, carbon. After involving in hybridization, after intermixing, after involving in hybridization, how many hybrid orbitals came? 4 hybrid orbitals. That 4 hybrid orbitals around carbon, you can write like this. 1, 2, 3, 4. And this is what again? 1, 2, 3, 4. Why? Because 2 carbons, no? Each carbon has sp3 hybridization. So what is the shortcut I gave? Both the sides, if it has single bond, no doubt that is sp3 hybridization. If you need concept explanation also I had given. Both you can use it. Okay, now finally next, what is the students? How many electrons are there? Here 1 electron, here, totally 4 electrons. See, this carbon has 1 electron, this carbon 4 electrons, right? And this carbon also 1, 2, 3, 4. One more carbon also, same story, hybridization. So sp3 hybridization, you will get like this. Now, students, I am explaining here. After hybridization, now overlapping will start. What is overlapping? Overlapping, I will show. See, this electron, here electron, and this carbon electron, both are opposite spins. See, here suppose same spin, this is plus half spin, this is also plus half spin, it will not exist. And here minus half spin, minus of both, repulsion, same charge means repulsion, it will not exist. That's why given box always we have to write one upward, one downward. Even overlapping time also one upward, one downward. These two are overlapping. Finally, we will get here between carbon and carbon single bond. And this is what type of bond? sp3. Electrons are overlapping. We have got sigma bond. So finally, you will get questions here. Hybrid orbitals overlapping, what is the bond formation? Which bond will form? Sigma bond. Never form pi bond. So hybrid orbitals intermixing, you will get in hybrid orbitals overlapping, you will get only sigma bond. You can expect questions from this area, students. Okay. Now, what is this? right? It is also electron. See, finally here overlapping sigma bond. Next, this is about hybridization. Now, in our hand, how many hydrogen students? C2H6. 6 hydrogens are there, no? Now, 6 hydrogens. This carbon, 3 hydrogens. Hydrogen means what is electronic configuration? 1s1. S orbital, what is the shape? Spherical shape. That's why I have drawn like this. Hydrogen electron now overlapping with the carbon hybrid orbitals. See, finally, I will get here also sigma bonds. Sigma bonds. Clear? Hydrogen, 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 and hydrogen. That's it. Now overlapping, 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 all overlapping. Finally, what is the bond here, students? See, I am drawing here structure once again. This between carbon and carbon we have single bond. What is the single bond name? sp3 sigma bond. Okay, and here three hydrogens, 1, 2, 3, right? So this is what we call it as sp3s sigma bond. sp3s, hydrogen is 1s, no? 1s, no? S is involving. That's why you can write like this, sp3s. So here also same story. So finally, so I am writing here how many sigma bonds totally, students? How many sigma bonds? All single bonds. 1, 2, 3, 4, 5, 6, 7. 7 sigma bonds we have got it. Out of 7 sigma bonds, 1 is sp3 sigma bond and remaining 6 are sp3s sigma bond. Okay, so clear? You have to give proper explanation. When it is theory examination, so don't expect too many questions. Just they'll ask in ethane molecule what is the hybridization, explain. But in competitive examination, out of 7 sigma bonds, type, actual type also they are asking. sp3, how many sigma bonds? sp3s, how many sigma bonds? This is mains and NEET level questions. Clear, students? Once again, go through the concept. If you have any queries, comment me. Definitely we'll discuss those points in section. Okay, now next one. Hybrid or sigma bonds calculation, you have got it. Now, hybrid orbitals, pure orbitals. Pi bonds also, if you have any queries, look into this. Ethane molecule, what is the structure, students? This is ethane molecule, right? Finally, how many sigma bonds here? 7 sigma bonds, 0 pi bonds. This is one question. Next, ethene. Write the names also. Sometimes they won't give molecular formulas. You have to remember. Ethene, C2H4. This is what? Molecular formula C2H6, right? So, C2H4. What is this? We call it as ethene. Ethene, double bond, H, 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 H. Ene means double bond. Ene means single bond. Ene means at least one double bond. Remaining filled with hydrogens. Around carbon always 4 bonds. 1, 2, 3, 4. This carbon also 1, 2, 3, 4 like this. Okay, students, can you tell how many sigma bonds here? 1, 2, 3, 4, 5. 5 sigma bonds, 1 pi bond. But there 0 pi bond, right? In out of 5 sigma bonds, the same way if you go for explanation, this is sp sp2 sigma bond, sp2 sigma bond 1, and remaining 4 sigma bonds are sp2s sigma bond. Okay, so only one example I had explained clearly. Remaining examples I am writing directly. If you have any queries also, comment me. We'll discuss coming days. Okay, now C2H2. What is the C2H2 called? Ethene. Ethyne. Ethyne. Ine means double bond or triple bond. Ane means single bond. Ene means, yes, double bond. Ine means triple bond. C triple bond, C H H, like this, students. Clear? So can you count sigma bonds? 1, 2, 3. 3 sigma bonds and 2 pi bonds, right? So if they asked a question here, special questions. What is the special questions? How many sp hybridization, right? Why it is sp hybridization? Triple bond is there, no? So I am writing here, down I am writing. So out of 3 sigma bonds, one is sp overlapping sigma bond, and another two is sp sigma bond, like this. Clear, students? Okay, hope everyone clear. Now I am going for explanation of hybrid and pure orbitals. And sigma bond calculation, I am giving one more shortcut to you, students. Sigma bond calculation, most of the students, they are confusing after writing sigma bond, after calculating sigma bonds. To avoid this one, I am giving one shortcut, so it is very easy. So shortcut. Sigma bond calculation. Number of carbon atoms minus 1 plus number of other atoms. Other atoms. Is it applicable or not? Check it. See here, ethane molecule, C2H6. Number of carbon atoms, 2, minus plus number of other atoms. Other atoms, how many, students? 6. 2 minus 1. 2 minus 1. How much? 1. 1 plus 6. Totally 7 sigma bonds. Clear? So like that, we can do sigma bond calculation shortcut questions. It is applicable for only long chains like this. If they had given benzene ring structures, no, this shortcut is not applicable. You can apply the same thing here. Is it matching or not? See, how many carbons here? 2. 2 minus 1. 1 plus totally how many other atoms? 4. So 1 plus 4, 5. That's it, students. Easily you can work out the sigma bonds calculation, pi bonds calculation. Okay, pi bonds, it's very easy. Out of 2 bonds, 1 pi bond must, and out of 3 bonds, 2 pi bonds must. Okay. Now next, calculating hybrid orbitals, hybrid and pure orbitals. I am taking ethane molecule, CH3, CH3. See, just now we have seen what is the hybridization, students, here. Your hybridization is sp3, single bond means sp3. So sp3 means 1s, 3 p orbitals involving. 1s, 3 p orbitals involving. Here 4 hybrid orbitals in my hand. Here 4 hybrid orbitals in my hand. 4 plus 4, totally how many hybrid orbitals, students? 8 hybrid orbitals. See how easy it is, calculation of hybrid orbitals. Clear? Now this is next, pure orbitals. Pure orbitals. How to calculate pure orbitals? Check it. Just you write the expanded form, students. We have discussed concept just now. See, this is what hybrid orbit. What is this hybrid orbitals? sp3 hybridization. After hybridization, after completion of hybridization, now hydrogens came and overlapping. This hydrogens overlapping is, we call it as pure orbitals. So hydrogen is not involving in hybridization. Only carbon involving in hybridization. Around carbon we have got 4 hybrid orbitals. In above case I had explained. After hybridization, hydrogen is coming and overlapping. That overlapping bonds only we call it as pure orbitals. Finally, how many hydrogens here? 6 hydrogens. 6 hydrogens means 6 pure orbitals. 6 pure orbitals. Clear? Next, ratio. If they asked question ratio, what is the answer, students? Anyone got it? What is the answer? Yes. Can you try? 8 is to 6. Clear? 4 is to 3. Right? So ratios they're asking. Now, hybrid orbitals calculation students are not doing mistakes, but pure orbitals time students they are doing mistakes. To avoid this one, here pure orbital calculation also, I am giving one shortcut to you students. Look into this shortcut. So pure orbitals, how to calculate? So what is this? Carbon atoms, number of atoms other than carbon, number of atoms other than carbon, atoms, carbon plus 2 into number of pi bonds. 2 into number of pi bonds. Okay, don't confuse. Look into ethane molecule, is it working or not? We'll come to know. Pure orbitals other than carbon, 6, right? Plus 2 into number of pi bonds. Any pi bonds is there? No. 2 into 0. 6 plus 0, that is equal to 6. See, here match. Clear? Like that. Now work out other questions, students. Ethene, ethyne, benzene. So all ratios they're asking. Sometimes they're asking hybrid orbitals. Sometimes they're asking pure orbitals. Next question 2. C2H4. That is what we call it as ethene, right? So expanded form you can write CH2 double bond CH2, right? So at least one side double bond. This is the structure of ethane, right? At least one side double bond. What is this? sp2 hybridization. This is what sp2 hybridization. sp2 means how many hybrid orbitals? 1 plus 2, 3. 3 hybrid orbitals. Here 3 hybrid orbitals. Here 3 plus 3. Totally 6 hybrid orbitals in our hand, right? Next, pure orbitals. Can you calculate pure orbitals? Here pure orbitals, little confusing students. Here 4 hydrogens are there, no? Because of 4 hydrogens, 4 pure orbitals plus 1 pi bond is there, no? 1 pi bond. Because of 1 pi bond, 2 pure orbitals. 2 pure orbitals, 4 plus 2, 6. Okay. So actually hybridization time we have discussed. This is after bond formation. Unhybridized p orbital is, okay, let me draw the structure. Sigma bond, no problem. But one unhybridized p orbital is there. sp3 means all atomic orbitals, all electrons are all atomic orbitals involving. But sp2 means one is not involving. That in not involving one electron is like this. This is sidewise overlapping. Because of sidewise overlapping, you will get pi bond. You will get pi bond like this. Okay, because of this one pi bond formation means how many orbitals are involving? 2 orbitals are involving. That's right, 2. So 4 plus 2, 6. Suppose if you are confusing, apply the shortcut. Apply the shortcut. You will get the same number. So finally, what is the ratio here, students? Ratio 6 is to 6 means 1 is to 1. Right? That is 1 is to 1. Easy, students? Easily you can calculate like this. 6 is to 6, 1 is to 1. Finally, next question. C2H2. What is the C2H2? We call it as ethyne. Ethyne. Right. Ethyne, write the structure. CH triple bond CH. See, at least one side triple bond. What is the hybridization? Yes, C. Right. sp means 1 plus 1, 2. 2 hybrid orbitals are involving. If 2 hybrid orbitals here 2, here 2, totally 2 plus 2, how much? 4 hybrid orbitals. Then Apply the shortcut or else two hydrogens. Because of two hydrogens, pure orbitals, and because of two pi bonds, no, one pi bond means two pi bonds means four. Four. So four pure orbitals, two plus because of two hydrogens, because of pi bond. So 4, 2 plus 4, totally 6. Totally 6. So here what is the ratio, or else apply the shortcut and check it. Okay. Now ratio. Can you give the answer? Ratio. Yes. 4 is to 6. 4 is to 6. 4 is to 6 means what is the answer? 2 is to 3. 2 is to 3. Here students, now next one, another example. Another example, what I am giving here, benzene. Benzene. Benzene, this is benzene structure. Alternative single and double bonds each. This is carbon, each carbon having one hydrogen. So each carbon involves here sp2 hybridization. Why? Because at least one double bond is there, then what we call it as sp2. How many? 6 carbons. 6 carbons, sp2 hybridization. sp2 hybridization is how many hybrid orbitals? 3. 1 plus 2, 3. 6 into 3, 18 hybrid orbitals in our hand. Pure orbitals, how to calculate students? Each hydrogens. How many hydrogens? 6 hydrogens plus and 3 pi bonds. 3 pi bonds means 6. 6 pure orbitals. 6 plus 6, totally 12 pure orbitals. Okay, ratio. Ratio students, can you calculate? 18 is to 12. 18 is to 12 means what is the ratio? 3 6 jar. 2 6 jar. 3 is to 2. That's it. Clear point? Hybrid orbitals, pure orbitals. Check it all the examples. Now, next topic, students. Bond order. Bond order. Bond order is nothing but simply number of bonds between two atoms. Number of bonds between two atoms. C single bond alkane, C double bond C triple bond C. Can you tell how many bonds here? 1. Bond order is 1. Here 2 bonds. Bond order equal to 2. Here 3 bonds. Bond order equal to 3. Right? Next, second point. Bond order directly proportional to bond energy. Bond energy. So here 1%, 2%, 3%. Fighting with 3% is very difficult, right? Person 2 is there, okay, but 1 is there, very easily we can fight. Very easily we can break. Here breaking difficult. Here breaking more difficult. So where bond order more, there bond energy also more. Bond order directly proportional to bond energy. Here which is bond order, can you tell? C triple bond C has more bond order, and what is this? Bond order. C triple bond C, C double bond C, C single bond C. Even bond energy also same thing, same order. C triple bond C, C double bond C, and C single bond C. Now I am telling bond order inversely proportional to bond length. Bond length. If number of bonds increases, congested, like close each other, bond length definitely decreases. Simple. Bond length ulta. C triple bond C less than, C double bond C less than, so C single bond C. C single bond C bond length is more. And they are asking your values also, students. Let me give the values. Okay. So what are the values? C single bond C. Yes. C single bond C, 1.54 angstroms. This is 1.34 angstroms. This is 1.21 angstroms. 2021. That's all. See, bonds increases, bond length decreases, right? So next, they are asking here one more question. So write bond length order of alkanes, alkenes, alkynes, and benzene. Alkenes means C single bond C, C double bond C, alkene, C triple bond C. A benzene means just now we have drawn the structure, right? So in which case bond length is more? Definitely alkenes. Alkenes, what is the bond length? CC bond length 1.54. Next one, benzene, student. Why benzene? So benzene has both single and double bonds. That's why its bond length lie between these two values. Its value is 1.39. Only single bond 1.54. Only double bond 1.34. But benzene lies between these two. Reason behind is it has two types of bonds. Clear? So this is 1.39. Then alkenes. Alkenes, what is this? 1.34. And last one is alkynes, right? C triple bond C 1.21. This is one of the most important frequent question in our competitive examination. Anything, bond order they will ask, bond energy they will ask, bond length they will ask, anything. Anything. Okay, now next one. Bond angle. Bond angle, it can vary, depends on lone pair. Bond angle is nothing but angle between two adjacent atoms. Angle between two adjacent atoms, right? So now look into this. Suppose if you have taken beryllium molecule, beryllium chloride. In beryllium chloride, so like this. It is linear shape. It is linear shape. Bond angle between two atoms. Between two atoms. What is this bond angle here? 180 degrees. 180 degrees like this. 90, 90. Totally 180 degrees. Suppose if you look into ethane molecule. Ethane molecule. This is tetrahedral shape, right? See, between these two, and between these two, what is this bond angle? 109 degrees, 28 minutes. Now, NH3 molecule. NH3 molecule also sp3 hybridization, but bond angle is decreasing. The reason is lone pair. Lone pairs present on central atom, repulsions increases. To avoid this repulsions, then what happened? So bonds decreasing, bond angles decreasing, and shape also changing. So here 107 degrees. If you look into water molecule, it is bent shape, students. Bent shape. Here bond angle 104 degrees. This is the guy sp3 hybridization. This is the guy sp3 hybridization. This is also sp3 hybridization. But the bond angle depends on lone pairs. Depends on lone pairs. Lone pair increases. What happens? Bond angle decreases. Valence electron pair repulsion theory was studying the same thing, no? Lone pair repulsions greater than, lone pair repulsions greater than, bond pair. So lone pair repulsions greater than, lone pair repulsions greater than, bond pair. Only bond pairs is there. Already bond formation takes place, no? Then he is busy. But no repulsions much. There is no repulsions. There is no repulsions are there. Only bond pair repulsion, that is very less. But that's why bond angle 109 degrees 28 minutes. That is tetrahedral shape means definitely 109 degrees 28 minutes. Here also we have expected the same thing. But lone pair is present. This lone pair and bond pair repulsions. Bond pair between two bonds, bond pair. Between one lone pair and bond pair bond pair repulsions. That's why bond angle decreases. But here all type of repulsions. Lone pair, bond pair. And next lone pair. Next, lone pair, bond pair, bond pair. All type of repulsions are there. Let's say little more decreases. Clear, students? Next, last one, electronegativity. Electronegativity also one of the important question. Let me cover. Electronegativity. Alkanes, alkenes, alkynes. C single bond, C double bond, C triple bond, C. So alkynes are more electronegative. More electronegative. Alkynes carbon. Alkynes carbon. Alkynes carbon more electronegative. Reason due to more S character. Due to more S character. Your sp hybridization. This is sp2. Right? This is sp3. sp3. How to calculate? So sp3 means how many? 1 plus 3 plus 4 hybrid orbitals, right? But 1 by 4. S means 1s. Total by 4. 1 by 4 means 25%. If you calculate percentages, 25%. This is 3 by 4. 3 by 4 percentage of the P character. This is percentage of S character. This is percentage of P character. The similar way you can calculate your. So here you will get S character is percent and P character also 50%. Where S character is more, where S percentage is more, that is more electronegative. These carbons are more electronegative. How can you say? If you look into hydrogens, this one, these hydrogens are ready to lose. Ready to lose. Who is losing fastly? Hydrogen. That is acidic in nature. Why is losing? Carbon is more electronegative, no? He is attracting electrons towards itself. Such a way bond between carbon and hydrogen is weak. He is fastly losing. Fastly losing is nothing but acidic in nature. So you will expect questions like this in competitive examination, students. Okay. So definitely it is useful before the examination. So try it once again. If you have any queries, also comment me and use all of you, and afterwards you can work out the questions. Definitely you will get good marks and improve your marks exam to exam. So chemical bonding, this is sixth part. Next to two more parts is there. Molecular orbital theory, hydrogen bonding also I am going to explain, students. All the videos you can watch, you'll get more benefit. Thank you, students. Thanks for watching. Subscribe our channel. You will get every day two videos. First year topics and second year topics also I am doing. That is later you can do. But first year topics you concentrate now and get good marks. Thank you, students. Thanks for watching. And who are going for final NEET exam and final mains preparation also, useful videos. This is short revision. Thank you, students. Thanks for watching.